Dealing with duplicates and inconsistent data in Pandas. In real-world datasets, messy data is very common. Duplicates and inconsistencies can affect your analysis and model quality. Today, we will learn to find and fix duplicate rows, handle missing or inconsistent values, and clean up your data frame with confidence. We will use the famous Titanic dataset to get hands-on experience. Let us get started. Running the cell now. We first turn off warnings so they do not fill up your notebook. Now we will set up the Titanic dataset so we can start exploring. We import the Pandas library. Import numpy as np. We set the random seed to 42 for reproducibility. We load the Titanic dataset from an online source into a data frame. This reads in our Titanic data table. Here is the shape, or the number of rows and columns, in our data frame. Here is a quick preview of the first 3 rows to see the structure. Running the cell now. Here, we see the initial Titanic dataset with 891 rows and 12 columns, confirming the data size and structure before cleaning. Notably, the sample rows show potential inconsistencies such as missing cabin values, NaN, and mixed types in the ticket column, highlighting why careful cleaning is necessary. This sets the stage for identifying duplicates and handling missing or inconsistent values in the next steps. Try loading the Titanic dataset yourself and see how many rows and columns appear. What are duplicates and why do they matter? Duplicates are rows that are identical in all columns. Sometimes data gets entered twice, or combined from multiple sources. Duplicate rows can throw off your analysis or statistics. Let us find them using Pandas. Running the cell now. Now let us look for duplicate rows by calling the duplicated method. This creates a new data frame with only the duplicate rows. We display how many duplicates were found overall, so you can see how big the issue is. We preview the first 2 duplicate rows, if any, to understand what they contain. Running the cell now. This output shows that there are 0 duplicate rows in the dataset, meaning every passenger entry is unique across all columns. The intent of this code was to check if any exact copies of rows exist, which could bias analysis. Here, we confirm the data is clean in that regard. Noticing the full shape, 891 rows, an empty duplicate result helps ensure our subsequent analysis starts with reliable, non-redundant data. Try the duplicated method on your own dataset to see if any duplicates show up in your tables. We can remove duplicate rows to get a cleaner data frame. This creates a new data frame that has all the unique rows only. We print out how many rows remain, to see the difference. Running the cell now. This output shows the number of rows after removing exact duplicate rows from the dataset, which is now 891. Notice how this step ensures each record is unique, preventing duplicated data from skewing your analysis. The intent of this code is to clean the data by eliminating redundant entries that could distort any insights or statistics derived from the dataset. We can remove duplicates where just one column matches, such as passenger name. This creates a data frame where a name appears only once per person. Now let us see how many unique names we have left. Running the cell now. This output shows that when removing duplicates based only on the name column, we still have 891 unique entries, matching the original row count. This indicates there were no repeated names in the dataset, highlighting how duplicates depend on which columns you consider. The code's intent is to demonstrate that removing duplicates by one column can affect your data differently than removing duplicates by all columns. Try using drop_duplicates with different columns to see how it changes your data. Spotting and fixing inconsistent data. Real-world datasets often have slightly different entries for the same thing. For example, male, male, and male might all appear in the sex column. Misspellings or weird formatting sneak in. Let us scan the sex and embarked columns for inconsistencies. Running the cell now. Let us ask Pandas to show us all the unique values for sex and embarked. This prints out every unique way sex is spelled or formatted in the dataset. It does the same for the embarked port codes, so we can scan for typos or missing info. Running the cell now. This output shows the unique values in the sex and embarked columns. Notice that sex has only lowercase male and female, indicating consistent formatting, while embarked includes 3 categories plus a missing value, nan. The code helps us spot if there are inconsistent or unexpected entries that need cleaning before analysis. Pick a column and use .unique to discover inconsistent entries in your own data. Here, we make everything in the sex column lowercase, so a male and male a match. This overwrites the column so we standardize the values for easier analysis. We print the unique values again to check that it worked. Running the cell now. This output shows the unique values in the sex column after standardizing all entries to lowercase. Notice that all variations like male, male, or the male have been unified into just male, and similarly for female. This confirms the code's intent to clean inconsistent text data for more reliable analysis. We are going to fix inconsistent or missing codes in the embarked column. If there are any missing values for embarked, let us fill them in with the word unknown. We strip extra spaces and switch every entry to uppercase, so codes match up. Finally, we show how many times each value appears so you spot rare or weird entries. Running the cell now. This output shows the clean distribution of values in the embarked column after fixing inconsistencies. Notice that all entries are uppercase and blanks are replaced with unknown, revealing clear count differences that make analysis more reliable. This confirms the code's intent to standardize entries and handle missing data for accurate summaries. Try cleaning a text column with both .str methods and .filter to unify the data. Now let us look for any codes in embarked that are not expected. We define which codes are allowed here, C, Q, S, or unknown. This pulls out any rows where the code is not on our list. We print a few examples so you can decide how to handle strange codes. Running the cell now. The output shows an empty data frame, meaning there are no unexpected or misspelled values in the embarked column beyond our defined valid codes, C, Q, S, unknown. This confirms that the embarked data is consistent, which is crucial before moving on to further cleaning or analysis steps. Practice finding oddball values in one of your data frame's string columns. Sometimes names or text are in all caps or all lowercase. Let us fix that. We use title case so every word in a name starts with a capital letter. We look at the first 2 rows to make sure it looks clean. Running the cell now. The output shows the first 2 entries in the name column after applying .street title, which standardizes capitalization by capitalizing the first letter of each word. Notice how names are now consistently formatted, fixing inconsistencies like all lowercase or all uppercase entries. This step is crucial to clean data for easier searching and analysis later in the workflow. What about missing values? Data might be missing because not everyone answered every question. Let us find out how many values are missing in each column. Pandas can help us quickly spot columns that need fixing. Running the cell now. With one command, we count the number of missing values in every column. Now you know where you have gaps or incomplete data. Running the cell now. Here, we see the count of missing values for each column in the dataset. Notice that the aged column has 177 missing entries, and a cabinet has a large number with 687 missing, highlighting these columns may need attention before analysis. This quick summary helps us identify where to focus our data cleaning efforts. Try filling in missing values or removing those rows to experiment. It is common to fill missing numeric values with a summary number like the median. We compute the median age. The median is the value in the middle when sorted. We use filter to copy the median into any missing spot in age. Afterwards, we check that there are 0 missing age values left. Running the cell now. The output shows that there are now 0 missing values in the age column, confirming that the median age successfully filled all the gaps. This step is crucial to ensure our dataset is complete before analysis, preventing errors or biases caused by missing data. Filling missing values with the median is a simple yet effective strategy when handling incomplete numerical data. Sometimes, it makes sense to remove rows that are missing very important fields. Here, we drop every row where a cabin is blank. We print the shape to see how much smaller the dataset is now. Running the cell now. After dropping rows with missing cabin values, the dataset shrinks to 204 rows and 12 columns. This tells us a significant number of entries had missing cabin data, highlighting the impact of cleaning on dataset size. It's important to notice this reduction when deciding how to handle missing values without losing too much information. Decide when to drop or fill missing values for best results. This is a mini-challenge about cleaning a small example dataset. You need to fix duplicate rows or inconsistent data in the given data frame. Here is the table with columns, name, country, and age. This line shows the column headers with separators for the table format. This row has Sam Smith from USA, age 33. This row has a duplicate with different casing, Sam Smith from USA, age 33. This row has Eva Lee from Canada with a missing age. Running the cell now. Pause and play with the sample above. Post your best solution in the comments, and do not forget to like and subscribe if you are enjoying the lesson. Introduce a complete data cleaning pipeline for the Titanic dataset. Create a clean data frame by starting a method chain on the original data frame df. Remove any duplicate rows from the data frame. Begin assigning new cleaned columns in the data frame using the assign method. Convert all entries in the sexa column to lowercase for consistency. Fill missing values in embarked with unknown, then strip white space and convert text to uppercase. Convert the name column to title case to standardize formatting. Fill missing values in age with the median age from the column. Close the method chain by assigning the result to df_cleaned. Display the first 3 rows of the clean data frame to review changes. Running the cell now. This output shows the first 3 rows of the clean Titanic dataset after removing duplicates and standardizing key columns like sex, embarked, name, and age. Notice how sexa values are lowercase, embarked is uppercased with missing values filled as unknown, name is title-cased, and missing age is replaced by the median, ensuring consistent and complete data for further analysis. This demonstrates the power of chaining transformations to create a clean, ready-to-use data frame in one streamlined pipeline. Cleaning up your data and then saving it makes your next analysis easier. This writes your new tidy dataset to a CSV file without row numbers. Now you have a ready dataset for future projects. Running the cell now. The output confirms that the clean data frame has been successfully saved to a CSV file without the index column. This step finalizes our mini-challenge by preserving the corrected data, free of duplicates or inconsistencies, for future use or analysis. Noticing this message ensures you completed the cleaning process and stored the refined dataset properly. Recap. Duplicates and inconsistent values are very common data issues. Use duplicated, drop_duplicates, string functions, and fillna to fix them. Always check for missing values and odd entries. A clean data frame means less stress and better results. Running the cell now. Thank you for working through this lesson. Try these techniques on your own data projects. If you learned something new, like and subscribe for more beginner-friendly data science tutorials. Running the cell now.